Okay, so guys, here's the deal. I was super happy with how we just did the POD. I did not think that was going to go so well, so kudos to you all. So here's the deal today. We are just going to transition those ideas into inequalities. So it's going to be the same things you already know. Breathe. I already see you panicking. Breathe, because really, we aren't adding anything new. We're just merging what we did in the POD, for example, with our key terms. So some of those key terms that we've learned are, is at most. What does is at most tell us to do? What symbol?
Oh, just kidding, less than or equal to.
Right, so is at least, what's that?
Greater than or equal to.
Is no more than.
Less than or equal to.
Right, not more than, so less than or equal to, and is no less than, right? These are terms that we already had on the table. These are things that we should already know. Okay, we're just going to merge that idea with what we've already learned about story problems. Okay, so if we look at number 1 up here, Alonzo is raising money for dance marathon. He plans to sell cookies during school sporting events. He will need to spend 9 cents per cookie package he sells on cooking supplies. Alonzo will then sell them for 75 cents. He also knows that he will need to put up some posters to advertise, which will cost him $38. Everything up until this point reads exactly like what we just saw in the POD, right? Where we should recognize at this point that this is a comparison, and the type of comparison that it is making versus spending, right? Right now, nothing is different. So we'll have making versus spending. Okay, but now here is the difference. This last question. What is the minimum number of cookie packages Alonzo will need to sell in order to start making money? Okay, so now we're not just saying what is the exact number where we might make money, right? We're saying there's a whole lot of amount of cookie packages that we can sell that we will make money off of, right? And we want to find all of the numbers that will make us a winning amount. My students actually like this better because it tells you which way to route. So if Alonzo wants to start making money, does he need to make more or does he need to spend more? Make more. So we need making to be larger than spending. Can the making amount be equal to the spending amount? Why not?
Because you want to make more.
We want to make more, right? We don't want to just break it. We want to actually start putting money in our pocket. So we want that greater than symbol. Everything at this point is then the same. There's literally nothing different.
So the only thing different is deciding on which inequality sign you need.
Yep.
Oh.
Okay, so he will need to spend 9 cents per cookie. Is that making or spending? Spending, so I'm going to put that over here. He will then sell them for 75 cents. Is that making or spending? Making. Okay, he knows that he will also spend $38 on posters to advertise. Making or spending? Spending.
You put it making.
Oh. Good grief. Thanks. Okay, we're going to bring our inequality symbol down. Just keeping that the same. What gets a variable?
75 and 0.75 and.
Why?
Because
Right? It's per item. It's per our number of cookies. What operation are we going to put here?
Addition. Will we ever put anything other than addition?
No, because it's the total. I mean, I can't. No, not really in a situation like this.
does it matter if you like have like 0.09 x plus 38 is less than 0.75?
Right, no it doesn't. So if you set this up and you put spending on this side and making on this side, it's fine as long as your alligator is eating the spending for all you alligator people, right? You want to make it set up so that the making is always larger than the spending, or the spending is less than the making. And at this point, we know how to solve. We've been solving great, so we'll just start solving this. Are we getting 57.57 repeating? Okay, so that says x is greater than 57.57 repeating. Here's why my students actually like the inequality more. So remember when we were talking about when you should round up and when you should round down? Here it tells you exactly what you need to do. We need a number that is greater than 57.57. So what is greater than 57.57? 58, 60, 65, 150, 2,573,652. Right? So Alonzo needs to sell. Oh, I need a new color again. Alonzo needs to sell more than 58 cookies. 58 cookies would be the minimum amount to start making money.
Wait, why do you round up instead of down?
Because this inequality symbol tells me I need a number that's greater than 57.57. 57 is not greater than that, right? So my next cookie package that's larger is 58.
Well, couldn't it also be 57.58 is larger?
But can you, it is larger, but can you sell that many cookie bags?
No.
Okay, so one of the things that we're going to talk about in our next unit is what are reasonable domain answers. Okay, what's reasonable to pick? I mean, 58.9 is larger too, but that's also not reasonable. So we'll give this more stipulations like numbers greater than 58 that are whole numbers. Right, so no fractions, no decimals, because we're not gonna sell a half-eaten cookie, hopefully. Right? Are we okay on that? Questions there? You feel okay? Pretty straightforward, right? Does that make us feel less stressed when we work through that problem? We're okay there?
It makes more sense now.
Okay, so this is one of the things that students say to me frequently. Part of the reason why we did that story problem unit is because story problems aren't going to go away. Part of the reason why we didn't give an assessment on that is because story problems aren't going to go away. We wanted you to see all of that info, so now as we start looking at them, my students are like, oh wait, well, that's a lot easier than it seemed then, right? The more you do something, the more you're like, oh, well, that's not so bad, right? That's pretty easy, okay? And that's exactly what should be starting to happen. Every time we work with story problems, there should be one more piece that just sort of goes, oh yeah, that makes sense. Yeah, I couldn't do that before, but I can do that now. So each time we sort of come back to them, which is gonna be multiple more times this trimester and next trimester and third trimester, one more piece sort of makes sense. Okay, so let's look at number 2. Alicia is going to gather stuffed animals to donate to a children's hospital. She finds a great deal and purchases 12 stuffed animals for $54. Each stuffed animal was the same price. If Alicia goes back to buy more stuffed animals at the same price, what is the maximum number of stuffed animals she will be able to buy with $100? Okay, that's a lot to take in. What type of story problem do we think this is? A total. Okay, so now we're dealing with something that we set up as a blank plus blank equals blank.
Total.
Right? Where our total is over here. But I didn't put in an equal sign because what words do we read differently this time? What word's different in here?
The maximum.
What is the maximum number of stuffed animals she can buy? So that's not saying she has to buy them all, right? That's saying what is the maximum potential. It's not just a single answer, right? We use an equal sign when there's one single possibility. We use an inequality sign when it's a sort of pick from a list of options. Okay, so if Alicia has $100 that she can spend. Can she spend more than $100 or less than $100? Okay, so we want to be less than the total of $100. Can she spend exactly $100?
Yes.
Yup, so this is going to be a less than or equal to. Are we okay there? Okay, one of these blanks should be pretty easy to fill in. What's our total? $100. That's the easy blank. Now we got to use our brains. This has got a little bit of a little trick to it we have to consider. What is Alicia purchasing? Stuffed animals. How much do those stuffed animals cost?
54.
Nope. That would be a good thought. Say it again. 12 for 54?
We don't know how much
It's
it
12
costs.
eggs.
Okay, we don't know how much they cost exactly, but we do know that it's 12 for 54. Okay, so you go to a place you buy scrunchies, and it's 5 for $20. How much is each scrunchie? $4. How do we know that? We divide it. So if it's 12 for $54, we want to divide it. So let's figure out how much a stuffed animal is. I mean, this person weirdly likes stuffed animals. Maybe it's like my daughter who's obsessed with them.
4.5. So
What did we get? 54 divided by 12 gave us what?
4.5, so it'd be
$4.50?
Yeah.
Okay.
Oh.
So we have $4.50 per stuffed animal. So what do we want to put in one of the blanks up here? $4.50.
why are you putting on that side? Does it matter which one you goes in?
It doesn't matter. I picked it for a reason because what goes in this blank?
12.
12 eggs. Because 12 stuffed animals, each stuffed animal.
Just eggs.
Okay, so does this get an X? Does this 450 get an X?
Oh, wait, it's just
Yes,
eggs.
right?
Yes, because it's 450 per stuffed animal. Why are you confused?
Used to. There's nothing over there.
What? We don't need that blank in this one. She's only buying one thing.
Whoa, that's gonna, I'm gonna fail the test.
No, you're not. We've done this before. You just are forgetting at the moment. She's just only purchasing one thing. Stuffed
I
animals.
hate these questions.
No, you don't.
No,
You're fine.
trick ones are the same.
That was a trick, not my trick.
Now, there is this trick that you do have to figure out the cost of each stuffed animal. Because this is stuff you do all the time in your head. Right? If it's 5 scrunchies for $20, oh, it's $4 a scrunchie. Right? You had no problem doing the math right there. Right? You gave me that answer instantly. Same thing.
So now, I don't know.
So now we just have 450x is less than or equal to 100. How are we going to solve this?
Divide.
Divide by 450. I mean, it's all repeating anyways. What do we get?
22.
So what's our answer?
23.
No, 21. No, I meant 22. Sorry.
Because x has to be less than or equal to 22.22. Don't go all the way down to 21 because 22 is less than this, right? So she has to buy less than or equal to 22. Right? She can buy 22 stuffed animals, 21 stuffed animals, 20, 19, 18, 17, 16, 15, 14, right? She can buy all these amount of stuffed animals.
She could just buy one.
She could just buy one. She can buy none.
But they're for her children.
I would buy 22.
Okay, we're going to pause for a moment because I don't want to overwhelm you too much.